Bam! Here we go. The Crazy Hat Chemist. Chemical nomenclature. This is the fourth video in a series of 4. So this is actually a summary of binary covalent compounds, ionic compounds, and acid nomenclature all in one. So we're going to try to first figure out if it's a binary covalent compound, an ionic compound, or an acid, and then that is our mixed practice. So here we go. So mixed practice, we got barium thiocyanate. So barium and then thiocyanate. We're going to figure out, is that a binary? Is that an ionic compound? Or is that an acid? It's not an acid because it doesn't have acid at the end of it. It doesn't have prefixes, so it's not a binary covalent compound. So it's barium and thiocyanate. Those are the cation and anion combinations there. We're going to take that 2 plus and that 1 minus. We're going to take those absolute values of those numbers. That's that 2 plus and that 1 minus. We're going to flip those numbers, bring it down, and we're going to come up with our formula. That's Ba, SCN parentheses, and a 2 outside. It's important that you have that parentheses. The next one is mercurous phosphite. That is not an acid. It is not a binary nonmetal. So it's a cation anion. That's an ionic compound. And mercurous is Hg2, 2 plus, and phosphite is PO3, 3 minus. So we're going to take the 2 plus and the 3 minus, the absolute value of those, flip those numbers, the 2 and the 3, bring them down, and bam, it's got Hg2, parentheses 3, PO3 with a parentheses and a 2. Awesome. The next one is stannous oxide. That is not a binary nonmetal. It's not an acid, so it has to be an ionic compound. So stannous, that's a 2 plus, and oxide, that's a periodic trend charge on the periodic table. So it's SN 2 plus, O2 minus. We're going to take that 2 plus and that 2 minus. We're going to take the absolute value of those numbers, flip, bring it down, and then bam, we're going to have to reduce this one. So we get SN2O2, and then we're going to have to reduce those numbers to 1. That is a must on the reduction. The next one is chlorine. That's not an ionic compound, it's not an acid, and it is not a binary nonmetal. So here's my hint. It is a diatomic, and that is an L. That is an L on your forehead. I'm hoping you're seeing that L. There are L on your forehead. You're going to flip that down. You're going to look at it. You get a number 7. There are 7 diatomics, and chlorine is one of them. And that's that formula. That is Cl2 because it's di for 2 atomic. The next one is plumbic iodate. Plumbic is a 4 plus charge, and iodate is a polyatomic ion. Pb 4 plus, IO3 1 minus. We're going to take that 4, that 1, absolute value of those numbers, flip, bring it down, and we're going to get our formula Pb IO3 with a parentheses and a 4. You're well on your way, halfway here. Manganic hydroxide. Hydroxides are really popular. It's not an acid, not a binary nonmetal, must be an ionic compound. So that's Mn3 plus for the IC ending there, and a hydroxide is an OH1 minus. We're going to take the 3, the 1, absolute value of those numbers, take the bull by the horn, flip, bring it down, and then bam, MnOH parentheses and a 3. You most certainly need the parentheses and the 3 there. Otherwise, you only have 3 hydrogens and not 3 hydroxides. So make sure you really pay attention to the hydroxides. The next one is hypoiodous acid. It says acid, so it has to be an acid. So all acids has a hydrogen in front of it, and hypoiodous is coming from hypoiodite. And that is that polyatomic ion. See, the hydrogen and the hypoiodite is IO1 minus. We're going to take the 1 plus, the 1 minus, the absolute value of those numbers. Flip, bring it down, and there we go. I do have the AQ. Again, you don't need the AQ unless it's it has a polyatomic ion acid, so you don't need the AQ. Next one is ammonium arsenate. Ammonium is the only polyatomic cation you will more than likely deal with. And then arsenate is ASO4 with a 3 minus. So it's ammonium, NH4, 1 plus, and ASO4, 3 minus. That's different than ammonia. Ammonia is NH3, no charge. So we're going to take that 1 plus, that 3 minus, flip, bring it down, and there's our formula, NH4 parentheses 3, ASO4. The next one is boric acid. That's an acid because it has acid on it, and so it's going to have a hydrogen, and the boric is coming from the borate ion. So H and the BO3, 3 minus. So we're going to take that 1, that 3, the absolute value of the 1 and the 3, flip the numbers, bring them down, and we get H3, BO3, and again, the AQ is grayed out, so you can have it, you cannot have it, it really doesn't matter. The next one is nitrogen trioxide. So there's a prefix on this one. So I'm going to have a nitrogen and an oxygen. How many nitrogens? 1. How many oxygens? Tri, and that's for 3. So you just take those numbers and bring them down. There's no charge. These are not put together by charge ratio. So you get NO3. Fantastic. That's our first set of mixed practice. We're going to flip to the next slide, and we're halfway through this whole lecture. Here we go. Next one is going from the formula to the name. So again, what we're going to do on these is we're going to decompose these. We're going to take the CD and the number right next to the CD and the NO2 parentheses and that 2, that outside 2. We're going to take that outside 2 and the CD, and we're going to flip those numbers. And so we're going to decompose it so that we get the cadmium charge and the nitrite ion. And then we get the name, and this is an ionic compound, that is cadmium nitrite. The next one is a K, that is potassium, and then a hydrogen. And this is a very unusual case here. So the potassium and the hydrogen, it's really a hydride ion. Anytime you have a group 1, that's potassium, or a group 2 metal combined with a hydrogen, it's going to be that metal name hydride. So potassium hydride. Next one is scandium, that's Sc, and you can see the 3+ charge outside the parentheses on the BO4, 1 minus. So it's scandium hyperbromate, or just scandium perbromate. One or the other, it really doesn't matter. Next one is Fe, SCN parentheses and a 3. That 3 outside the parentheses tells you the charge on that Fe. That's an iron, okay? And that is an Fe3 plus SCN. That's thiocyanate. So it's a ferric thiocyanate. The next one has an AQ, but it also has an H and an NO3. So that H in the front tells you that it's an acid, and that NO3 is nitrate. So we're going to decompose this again, and we got the hydrogen and the nitrate, and so the 8 becomes ic, so it's nitric acid. Next one is a PCl5, and what you have to recognize here on this one is you have 2 nonmetals. 2 nonmetals, that's a phosphorus and a chlorine. How many phosphorus do you have? 1, so it's phosphorus. How many chlorines do you have? 5. The prefix for 5 is penta, so it's phosphorus pentachloride. The next one has an Hg, and that's a mercury. We just got to figure out which mercury it is, and that's a mercury 1 or a mercury 2. And right outside that mercury there, that Hg, is no number. So that must be that it is a mercury 2+. And then it's that HSO3, 1 minus. Okay, that's a hydrogen sulfite. So it's mercuric hydrogen sulfite. The next one is an Au, that's for gold, and a C2O4, that's a polyatomic ion. Notice that the 2 and the 4 do not reduce because the polyatomic ion oxalates C2O4, 2 minus. The 2 and the 4 cannot be reduced. So I'm decomposing this. That is the 1+ charge on the gold, so it's a gold Roman numeral 1, or you can use the common name, that's Orris oxalate. Next one is a magnesium and a nitrogen. We have a group 2, that's magnesium, and a nitrogen. So it's a metal and a non-metal, so it's magnesium, which is a 2+, and a nitrogen, which is a periodic trend charge of a 3-. So that is magnesium nitride. And our last one here on this page is a Cr with a 3+. You can see that 3+ charge on the outside, the parentheses for the Cr, and BrO3, and we've already discussed that one with an acid before, and that's chromic bromate. Chromic bromate. Fantastic. All right, so this was the 4th video in this series of chemical nomenclature. You should be done with your chemical nomenclature. You should look at my website for worksheet practice worksheets that will cover everything in this whole nomenclature unit. The other thing I want you to do is to make sure that you look at all my videos in all chemistry topics. So here we go. Crazy Hat Chemist. See you soon. See you then.